So I'd say circuit bending is taking any existing electronic device that's capable of generating audio signal and then manipulating it by changing components or changing the values of components, replacing components, just kind of altering the schematics of it into to produce some sort of sound other than the original intended sound. It's probably been popular for maybe 20 or 30 years now, I'd say. Reed Ghazala is the only person I know that's like credible towards kind of the founding of circuit bending. A lot of the Casio tone keyboards, SK1s and SK5s, and kind of the early sampling keyboards became really, really popular with circuit bending due to kind of the exposed like circuitry that's inside of them. Every piece of gear will have some sort of bends on it, but the more digital the gear gets, the less accessible it is. Well, I kind of was introduced to some of the more advanced concepts by a teacher here at Expression, and then just kind of went home and found some old keyboards at a warehouse I lived at and just opened them up. Like I had no idea what to do and how to do it, and then just kind of went at it and got like alligator clips, some 9-volt batteries, and just opened up a keyboard and started doing it. There's a lot of sounds on the electronic recordings and kind of the higher tier of people making experimental music that are just clearly not made by generic instruments. Like there's just no way to get those sounds without taking components and blowing them up basically and recording it. The most obvious way of using them would be just to sample them out, but then there's also the live application of just plugging a couple of keyboards into one mixer and then just kind of start going for performance purposes. Being able to make your own sound library of sounds that aren't not just unique to a synth patch that you made or a drum machine that you programmed, but really unique to the fact that no one is ever going to hear that sound exactly the same way other than that one time that it just happened when you messed up some keyboard or something is kind of desirable if you really want to catalog all that type of stuff. If it suits your fancy to open up Fruity Loops or Reason and just kind of use beats that 1,000 other people have used, then there's nothing wrong with that, but it certainly doesn't sound very good to me. It's not really that unique or that creative to just kind of regurgitate the same sounds back and forth.
So, you want to create your own circuit bent instruments. Here's a brief tutorial to get you started. First, find an item to bend. Thrift stores and flea markets are the perfect place to look. Any toy that makes noise will do, however, some are much easier to bend than others. Remember, there are endless possibilities for the devices that can be used to experiment with your own circuit bent sounds. It is recommended that only toys powered by batteries be bent. Plug-in devices have been bent, however, it's dangerous and certainly not for the novice. Some of the most notable toys to bend are Texas Instruments Speak and Spell, Speak and Math, and Speak and Read, or toy keyboards such as the Casio SK1. Needed materials include soldering iron and soldering wire. A sharp, narrow tip is recommended. You will need decent soldering skills to circuit bend. Drill or Dremel to add holes for mounting switches and other components. A set of small screwdrivers. Small wrenches may also come in handy. Wire clippers. Test leads. A multimeter. This isn't necessary but may also come in handy. Small toggle switches, push button switches, potentiometers, etc. These are used to activate and manipulate your custom glitches. As far as how you connect the points on your circuit board, the sky's the limit. Many people use light-sensitive photoresistors, solar cells, humidity sensors, and body contacts to draw unpredictable sounds from their bent devices. Audio output jacks, such as 4th inch, 8th inch, and RCA, will be using a 4th inch jack. Thin gauge wire. Most, if not all, needed materials can be purchased at just about any Radio Shack or mail-order electronic surplus store. Now, take apart your toy to expose the circuits. As you have the toy making noise, begin to bridge points on the circuit with your test leads. You will begin to hear strange glitches as you essentially short-circuit your device. You will find that the process of circuit bending is mostly trial and error. For any given toy, there may be thousands of possible combinations to go through before thoroughly exploring the potential of your bent sounds. Be patient and you will be greatly rewarded. You may notice as you're going through this process that the circuit will crash and stop making noise. You will need to reset it and may need to take out and put back in the batteries. If this becomes a common problem, a small reset switch can be installed on the wires connecting to the batteries. It is possible to burn out and destroy the circuit you're working on. Keep an eye out and do not connect points that create the following problems. A spark, a diminishing of electronic displays or lights, a pop from the speaker, a volume decrease, a humming in the speaker, a component on the board heating up, or the batteries heating up. When you find a glitch you like enough to keep, make sure you mark the points. Now you can add a switch to turn your sound on and off. Simply solder 2 wires connected to each point and connect them to a switch in the middle. As mentioned earlier, there are many different parts that can be used to bridge these points on the circuit board. Now a hole can be drilled in the housing of your toy and a switch can be installed. If you wish to add an audio output jack to amplify your sounds, or to add additional effects, you can simply wire a jack connecting to the speaker terminals. After you're happy with the amount of modifications to your circuit, put it back together and enjoy your new circuit bent instrument.